The term angular momentum is familiar in physics. If I say angular momentum in general, which points out the orbital angular momentum L is equal to r cross p, then r is the position vector, the vector r equal to I into x plus j into y plus k into z. Then L is our I into Lx plus j into Ly plus k into Lz. If you want to calculate r cross p, then substitute the value of position vector. Here I, j, k. The value of the position vector is x, y, z. That means ix, jy, kz, x, y, z. Then we should substitute the value of momentum operator p. Then this is our h cross by I, dou by dou x, x component of momentum, h cross by I, dou by dou y component of momentum, h cross by I, dou by dou z. This is z component of momentum. Now take h cross by I as a common term. Write down the rest of the things. I into this y dou by dou z minus z into dou by dou y. Then minus j into this term, x into dou by dou z minus z into dou by dou x plus k into this. See this is k, x into dou by dou y minus y into dou by dou x. Now we have to compare the coefficients of I, j, k. In the left hand side, I into Lx plus j into Ly plus k into Lz are present. In the right hand side, the coefficients of I, j and k are having some values. Now we have to compare the coefficient of I, j and k in order to get the values of Lx, Ly and Lz. Before that, we should rearrange this in the convenient form. Here I into Lx plus j into Ly plus k into Lz, which is equal to h cross by I into y dou by dou z minus z into dou by dou y plus j into, rearrange this term. This minus j, this is changed as plus j. If I bring this z into dou by dou x as a first term, z into dou by dou x minus x into dou by dou z plus k into the last term, x into dou by dou y minus y into dou by dou x. Now compare the coefficients of I, j, k on both sides. If I compare the coefficients of I, j, k, we can get the values of Lx, Ly and Lz. From the above equation, then the value of Lx equal to h cross by I into y dou by dou z minus z into dou by dou y. This is the value of Lx. Just coefficient of I is here Lx, here the coefficient of I is h cross by I into y dou by dou z minus z into dou by dou y. This is complex number, imaginary term, but this is vector orientation, I, j, k vector. The coefficient of I on both sides is Lx equal to h cross by y into dou by dou z minus z into dou by dou y. Now, see this term, h cross by I into dou by dou z. That is our p set. Then h cross by I into dou by dou y. That is py. So this is equal to y pz minus zpy. This is one form of Lx. Lx equal to ypz minus zpy. And multiply this equation I and divide this equation I. We can write minus ih cross. I square is equal to minus 1. Minus ih cross y into dou by dou z minus z into dou by dou y. This is also the value of Lx. Lx equal to minus ih cross y into dou by dou z minus z into dou by dou y. This is one form. Another one form is Lx equal to ypz minus zpy, because pz is equal to h cross by I into dou by dou z. Then py equal to h cross by I into dou by dou y. In this way, we can write the value of Lx in two forms. Similarly, if you compare the coefficient of j on both sides, we can get the value of Ly. See, Ly is equal to coefficient of j carries z into dou by dou x minus x into dou by dou z. See, this is equal to z into, here one h cross I is commonly present. H cross by I into this term. Z into dou by dou x minus x into dou by dou z. Now, z into h cross by I dou by dou x. This is our px minus x into h cross by I dou by dou z is pz. So z px minus x pz is the value of Ly. Or some other form we can write minus ih cross. Multiply this term by I divided by term I square minus 1. So minus ih cross z into dou by dou x minus x into dou by dou z. This is another one form. The value of Ly equal to z into px minus x into pz, that is equal to minus ih cross z into dou by dou x minus x into dou by dou z. Then if you compare the coefficient of k on both sides, if you compare the coefficient of k, we can get Lz. The value of Lz we can get Lz equal to h cross by I into x into dou by dou y minus y into dou by dou x. This is equal to x into h cross by I into dou by dou y minus y into h cross by I into dou by dou x. This is equal to x py minus y px. This is the value of Lz. X py minus y px. Then in some other form, this is equal to, see here, h cross by I. This is equal to minus ih cross x into dou by dou y minus y into dou by dou x. This is another one form. So the values of Lx, Ly, Lz are minus ih cross into, after the x we have to write y into dou by dou z minus z into dou by dou y. Then Ly equal to minus ih cross z into dou by dou x minus x into dou by dou z. Lz equal to minus ih cross, after z x should be coming, x into dou by dou y minus y into dou by dou x. These are the values of Lx, Ly and Lz. Then minus ih cross dou by dou z is our pz. So y pz minus z into minus ih cross dou by dou y is our py. So minus z py. That is another form. So this is changed as Lx equal to y pz minus z into py. This is another form, because minus ih cross dou by dou z is our pz, or h cross by I into dou by dou z is also pz, both are same. So y into pz minus z into py. This is equal to z into px, because minus ih cross dou by dou x is our momentum operator, x component of momentum, z px, minus x into minus ih cross dou by dou z is our pz. Here this is x into py minus y into px. So cyclically you can follow x, y, z, y, z, x, z, x, y. So in this way easily we may develop all the values of Lx, Ly and Lz. These are all the components of orbital angular momentum L. Now we should study the commutative relations between them.